In this lesson, we're going to write equations of lines, and the problems will refer to some lines being parallel and some lines being perpendicular. And you're going to want to write these lines in point-slope form and slope-intercept form. Okay, so let's kind of review a couple of things in terms of parallel lines and slopes and perpendicular lines and slopes. So one thing that most students remember is this, that when you have two parallel lines, they have the same slope. But keep in mind, though, we are talking about non-vertical lines. So if you have two non-vertical lines, so something like this, so these two lines are non-vertical, and they're parallel, then they have the same slope. And the reason we say non-vertical, so meaning not vertical lines, is because vertical lines don't have a slope. They have no slope. All right, so that's why we mention non-vertical lines. And then the second thing is this: if you are told that you have two non-vertical lines and they have the same slope, then you can automatically say that the lines are parallel. All right, and then here's where this comes in. So if you are told that you have two distinct vertical lines with undefined slope, then they are parallel. So if you are told that you have two lines that have undefined slope, which means that they are vertical, then you can automatically say that they are parallel. But you can't talk about their slope because there is no slope of vertical lines. Okay? Then for perpendicular lines, what most students remember about perpendicular lines and slopes is that if you have two lines that are perpendicular, then their slopes are negative reciprocals of each other. All right. Now, if you were to multiply those two slopes, you would get a -1. All right. So, for example, let's say the slope of line 1 is 2/3, and the slope of line 2, let's say, is -3/2. So you see that they're negative reciprocals of each other, right? So those two lines would be perpendicular. So these two lines are perpendicular. But if you multiplied the slope of the first line by the slope of the second line, if you were to multiply those, what that's saying is that their product, 2/3 times a -3/2, that their product, 2 times -3 is -6, 3 times 2 is 6, their product's -1. That's what that's saying. Okay? But what most students remember is that their slopes are negative reciprocals of each other. So if this is a positive 2/3 and those two lines are perpendicular, then the other one has to be a negative and then take the reciprocal 3/2. This one talks about that if the product, so if you're told that two lines, that when you multiply their slopes is -1, then you can automatically assume that the lines are perpendicular. All right. And then number 3 says this, that if you have a horizontal line that has 0 slope, so obviously you remember that all horizontal lines have 0 slope. Okay. This is number 3, that all horizontal lines have 0 slope. Then that horizontal line is going to be perpendicular to any vertical line. So no matter what vertical line you draw through that horizontal line, those two lines are perpendicular, meaning that they form a right angle. Okay? All right, so now let's look at some problems dealing with what we want to do today. So in this lesson, we're going to look at these two scenarios. So these two problems are here. And so the first one says this. The first one says, use the given conditions to write an equation for each line. And you want to do this in both point-slope form and slope-intercept form. All right, and so you're told in the first problem that you have a line that's passing through this point and is parallel to the line whose equation is this. All right, and so you want to find the equation of that line, of a line that passes this point and is parallel to the line whose equation is this. All right, so we are talking about parallel, right? So the line that goes to this point and this line here, they're parallel. So if you want to write the equation of a line in point slope form and slope intercept form, remember two things. So point slope form point-slope form is this. So y minus y1 equals the slope times x minus x1. Right, where m is the slope and x1, y1 is a point on the line. Okay? And then slope-intercept form is this. Y equals mx plus b, where m is the slope, and you remember that b is called the y-intercept. All right, so what we're trying to do in numbers 1 and 2, for that matter, is to write the equation of those lines with those given conditions. All right, so you're dealing with two lines. You want to find the equation of the line that goes to this point, but you are also told that whatever that line is that goes to this point, it has to be parallel to this line. Okay? So if what I would do is I would go straight to point slope form first. And so remember, if you're going to use point slope form, you have to know a slope, the slope of that line, and you have to know a point on that line. Okay? So point slope form, so this is going to be number 1. So number 1. All right, number 1, let me go ahead and do this. All right, so number 1, 1a. All right, so the slope of the line that contains the point, and remember, I'm interested in the slope that passes to this point, right? So it contains this point. So negative 3, 4 has to be the same as the slope of this line. All right, and why is that? Well, because they're parallel, right? So it has to be the same of that line. So y equals negative 3x plus 4. So this is already in slope-intercept form. So what's the slope of that line? Well, the slope of that line is negative 3. So then that means that the slope of the line I'm interested in is also negative 3. Okay? And so now we can go directly to point slope form. So go now to point slope form. All right, so remember, point slope form is this. It's y minus y1 equals the slope times x minus x1. All right, so I know the point on that line. The point of that line is negative 3, 4. All right, so negative 3, 4. So what I would do at this point also is label this x1, y1. So remember, that point goes into x1, y1. That's how we defined point slope form here, where x1, y1 is a point on the line. And then the slope, you're told, is negative 3. All right, so we're just going to plug in, and let's see what we get. All right, so here's what happens. So y minus y1, which is 4, equals the slope, which is negative 3, times x minus x1, which is negative 3. All right, now you gotta listen carefully. You want to make sure you use some of the algebra skills you know. So you know that x subtract the negative 3 means x plus 3, and so that's how you want to write this. So y minus 4 equals negative 3 times x plus 3. And so this is point slope form. That's point slope form. Okay, so that's part of your answer right here. All right, now the next part says this. You also want to write this in slope-intercept form. So to get this in slope-intercept form, remember you get y by itself. You solve for y. So let's go ahead and take this right here and go a little bit further. So now we need this. We need to write this in slope-intercept form. All right, and remember, slope-intercept form is y equals mx plus b. So basically what we have to do is we have to take this equation here and solve for y. So that's what we have to do. Okay, so now I'm going to go ahead and rewrite this over. So y minus 4 equals negative 3 times x plus 3. And then solving for y, we're going to distribute the negative 3. I get y minus 4 equals negative 3x minus 9. And then adding 4 to both sides, and notice I'm aligning my like terms, I get y equals negative 3x, a negative 9 and 4 is a negative 5. And that is slope-intercept form. That's your slope-intercept form. Okay? And so notice that those two lines, regardless of which one you use, if you look at this one, that slope is negative 3. Now remember, that's the equation. That's the equation of the line that goes to this point and is parallel to this line. And so notice that this line here has slope negative 3, and the line that goes to this point, negative 3, 4, also has slope negative 3. Okay? Now, before we go into the next problem, before we go into B, I just want to kind of show you what you just dealt with in terms of the graph. Okay? And we're not going to do that with all the others because we don't have the time. But I do want to do it with at least A. Okay, so basically what's happening is this. All right, so if you go back to A, we're going to look at this in terms of a graph and just kind of see if we understand what's happening. So if I go back to part A right here, and if I graph the line y equals negative 3x plus 4, all right, so remember to graph a line, this is in slope-intercept form. So I note that, remember, to graph a line, you need 2 points. So I know the y-intercept is 4. So I'm going to go ahead and plot that point. So here's the y-intercept right here, okay? And I also know that the slope is negative 3. So remember, rise over run, negative 3 over 1. So I'm going to go down 3, 1, 2, 3, and to the right 1. So this line here that I'm about to draw, that is the line y equals negative 3x plus 4. That's what that is. Okay, and so I'm going to go ahead and draw that line. Looks something like this. All right, and remember the problem said this. The problem said you want to find the equation. Now notice that equation here is this: y equals negative 3x plus 4. So you know the equation of that line. The equation of that line is this. Okay, but you want to find, what you want to do here is find the equation of the line that contains this point. All right, so I'm going to do this in blue. So the point is negative 3, 4, which is here. So you want to find the equation of the line that goes to this point and is also parallel to this line. All right, so it's also parallel to this line. So remember, parallel lines have the same slope, right? So if this slope is negative 3, then the line here that goes to this point has to also be what? Negative 3. So I'm going to use the idea of slope of rise over run. Negative 3 over 1. So I'm going to go down 3, 1, 2, 3, to the right 1, right here. And if I draw that line, right here, like this, then that blue line is the one I'm interested in. Okay? So what we found here, if I go back to our equation, see this equation right here? Y equals negative 3x minus 5. Y equals negative 3x minus 5. That is the equation of that blue line. That's what we just found. Okay? So if I had drawn this, you see it's not going through those points very well, but the negative 5 is your y-intercept. It should have, if I had done this a little bit better, see, it should have done something like this. Right here. See, my point's thick, so it didn't actually go through those lines very well, but that's what you should have done. All right. So those two lines are parallel. So you're given that this line, you want to know what's the equation of the line that goes to this point, parallel to this one. Well, that's it right here. That's what you found. Okay. So I just wanted to kind of show you what it was you were looking for in terms of a graph. All right. So that was number 1. Now let's look at number 2. So number 2 says, same thing, you want to write the equation of the line with this condition. So it passes through this point now, and is perpendicular to this line. All right, so different problem, but the first one dealt with parallel. The second one deals with perpendicular. All right. So the idea is the same. Now, in part A, you remember to find the equation of the line that goes to this point, you had to first of all determine the slope of this line, which was easy to do because it was already in slope-intercept form. And then since they were parallel, the slope of that line is going to be the slope of this. It'll be the same as the slope of this line. Here, though, they're perpendicular, but the problem is that this is not in slope-intercept form, right? So what we have to do first is get this in slope-intercept form. So this is going to be part B. So part B, we have to first of all write that equation in slope-intercept form. So this is number 2. All right, so number 2. All right, so number 2, we have to first of all write the equation 3x minus 4y minus 2 equals 0. We have to write that in slope-intercept form. So put this in slope-intercept form. Now remember why we're doing that, so we can figure out that slope, right? So we need to know the slope of that line. So once we know the slope of that line, then we know the slope of that line. All right, so to get this in slope-intercept form, what I'm going to do is, I'm going to just, what most of you probably do is you see how you have all 3 terms to one side, so it's probably easier just to take this term, bring it to the other side. So I'm going to add 4y to both sides. And so I get 3x minus 2 equals 4y. All right, and then I'm going to just go ahead and transpose the equations, transpose the sides of the equation. So 4y equals 3x minus 2. All right, then I got to get y by itself, so I'm going to divide both sides by 4, just like this. And so I get y equals, I'm going to write this as 2 fractions, so 3/4 x minus 2/4. Okay? Now, all I needed to know now was just the slope, right? I don't care about this y-intercept. I just need to know the slope of that line. So the slope of this line, the slope is 3/4, right? Okay. Now, let's go back to our problem. Okay. So I now know the slope of this line. In order to find the equation of this line, I have to know a point on that line, which I do, and I have to know the slope of that line. Well, the slope of that line is the negative, remember perpendicular, the negative reciprocal of the slope of this line. So therefore, the slope of the line I'm interested in is the negative reciprocal of this. So is negative 4/3. Okay? So now we can use point slope form. All right, we can use point slope form. Okay, so y minus y1 equals a slope times x minus x1. And so we can use point slope form because I now know the slope, so the slope is negative 4/3. And I know a point on that line. A point of that line, remember, is 1, negative 2. Now what I would do, again, like we did in the previous problem, is I would go ahead and label this as x1, y1. And now we just substitute. So we get y minus y1, which is a negative 2, equals the slope, which is negative 4/3, times x minus x1, which is 1. All right, now, keep in mind, though, that you want to rewrite y minus negative 2 as y plus 2. Remember, subtracting means adding the opposite. So y plus 2 equals negative 4/3 times x minus 1. That is point slope form. So that make sure you understand what point slope form looks like. Y minus y1 equals the slope, in parentheses, x minus x1. Okay? So that's point slope form. You're done with that part. So that's point slope form. What you want to do now is write this in slope-intercept form. So that's where we're going to get y by itself. So I'm going to go ahead and distribute the negative 4/3. So I get y plus 2 equals negative 4/3 times x is a negative 4/3 x. A negative 4/3 times a negative 1 is a positive 4/3. And then we're going to subtract 2 from both sides. And then just use your calculator at that point. Don't make it difficult on yourself. Use your calculator. So we have y equals negative 4/3 x, and then all I have to do is figure out what this is. So in your calculator, you have a positive 4 divided by 3, right? So watch. 4 divided by 3. And you want to subtract 2, and I get this. All right? So most of you should know, if not all of you, most of you should know that this negative 0.666 is what fraction? Negative 1/3. I'm sorry, 2/3, right? Negative 2/3. If you didn't, then your calculator, you can convert it to a fraction just by pressing second P or B like that, and then press equal, and you get negative 2/3. All right, so you get minus 2/3 right here. And so that is the equation of the line in in slope-intercept form. Okay? All right. So that is the answer to part 2. Now remember, if we were to graph this, the equation of that line right here that goes to this point and is perpendicular to this one is this. And let's go ahead and do that real quick. Let's just go ahead and graph it. Now keep in mind that the y-intercept here is a fraction, so we're going to have to estimate pretty well where it's located, so we don't kind of mess this thing up. So let's go ahead and graph this line here. So we're going to graph this line using slope-intercept form. Okay. So remember, to graph a line, I need 2 points. So I already know the y-intercept. The y-intercept is negative 1/2, right? So here's the y-intercept right here, negative 1/2, right here. Y'all see it? So I'm estimating. All right. So but it's right in the middle between 0 and negative 1 on the y-axis. From that point, though, I'm going to use the slope. The slope is 3/4. So that means I'm going to go up 3 to the right 4. All right, so here's how this is going to look now. 1, see, negative 1/2 to 1/2, that's 1 unit, right? Okay, so that's not going to be too difficult to do. So 1, 2, 3. All right, and then I'm going to go 4 units to the right. 1, 2, 3, 4. So this is the other point right here. So then I'm going to now remember, about the point's thick, so it may not look pretty well at the end, but we have the idea what we're trying to get. So this right here is the equation 3x minus 4y minus 2 equals 0. That's that equation. That's this right here. Okay, that's it. What I want to do though is find the equation of the line that contains this point and is perpendicular to this line right here. All right, so 1, negative 2 is right here, right? Here's 1, negative 2 right here. Okay, and so we found, listen carefully, we found the slope of that line, of that blue line I want to draw. The slope of that blue line I want to draw, remember, it's negative 4/3, right? So from this point, I'm going to go down 4, 1, 2, 3, 4, and then to the right 3, 1, 2, 3. Okay, so if I connect those points using a line, if I connect them just like this, then and if I were to measure this right here, that would be a right angle right here. Those two lines are perpendicular. So that's what you found. You found the equation of the blue line. So the equation of the blue line in slope-intercept form is this. So that's y equals negative 4/3 x minus 2/3. And it kind of looked like see right here, right below the negative 1/2, negative 2/3. Okay, so that's where it's supposed to graph the y up, intersect the y-axis. All right, so that's what we're doing here. Okay. All right, so that was number 1. Now let's look at number 2. So number 2, we have this. I'm sorry. When I said 2, that should have been right here. That should have been 1b. All right, so 1b. So this is 1b. All right, now let's look at 2a. Okay, so in 2a we have this. We have write an equation in slope-intercept form of a line whose graph satisfies the given condition. All right, so the graph passes through the point -5, -1, okay, and is perpendicular to the line whose graph is x equal 4. All right, x equal 4. Now keep in mind that x equal 4 is a vertical line. And remember, vertical lines don't have slope. Vertical lines don't have a slope. There is no slope. It's undefined, remember that. So the way I would do that is I would think about it in terms of a graph. All right, so here's x equal 4. So x equal 4, remember, is a vertical line. So here's x equal 4. So that's a vertical line. So remember, it goes through the x-axis at 4. So remember, x equal 4. X equal 4 means that all these x values is 4. That's what that means. No matter what y is, x is 4. Okay? You are told, though, let's go back to number 2a. You are told that the line passes through the point -5, -1. All right, so let's look at this. -5, -1. So -5, -5, -1 is here. See it? Right here, right? Okay. So -5, -1. And it's perpendicular to this line. So it's perpendicular. Okay, so listen carefully. So we have this vertical line. A line perpendicular to it has to be what kind of line? Horizontal. Horizontal, right? And so what's the equation of a horizontal line? The equation of a horizontal line is always y equal. And what's the y values on this line? Where does the graph cross the y-axis? At -1. So y equals -1. And so there's your answer. Y equals -1. So the answer to A is y equal -1. So I could not, I want you to make sure you understand this. I couldn't go just straight from here. I couldn't go directly to point slope form, although in the end I could. So listen carefully. Y minus y1 equals the slope times x minus x1, right? Okay. So I know I'm trying to find the equation. I'm trying to find the equation of the line that goes to this point. So -5, -1. So x1, y1. All I need to do is find the slope. All right, but be careful. So you may say, well, the slope of the vertical line is undefined. That's true. Okay, it is undefined. That is very true. But you're told that you want the equation, you want the equation you're interested in to be perpendicular to this line. So if this is a vertical line, then what's the slope of a horizontal line? Well, the slope of a horizontal line is 0, right? So now we know the slope. The slope is 0. So what we're going to do is substitute 0 into here, and then x1, y1. So we have y minus y1, which is -1, equals the slope, which is 0, because we know this is a horizontal line, right? So we had a vertical line. We're told that the line I'm interested in is perpendicular to this, so which means it has to be horizontal, times x minus x1, which is -5. And so I get y plus 1. And then 0 times anything is 0. So that's 0 on this side, right? And so if I get y by itself, because remember they said write it in slope-intercept form, which means get y by itself, I get y equals -1, which is what this is, which we figured out by just looking at the graph. All right, so that was 2a. 2a is a little bit harder to deal with. Now let's look at 2b. 2b says the graph passes through this point and is perpendicular to the line that has an x-intercept of 3 and a y-intercept of 5. All right, now you may want to look at what you're dealing with in terms of a graph. It may help. Okay, it does help. All right, so listen carefully. So our problem says this. Our problem says that the line that this is perpendicular to has an x-intercept of 3 and a y-intercept of -5, right? Okay, so which means that this line right here, this line crosses the x-axis at 3. That's what x-intercept means. So across the x-axis at 3. And it crosses the y-axis at -5. That's what y-intercept means right here. And so if I draw that line like such, right here, this is the line, this line is this line right here. All right? I am interested in the line, though, the equation of the line that contains this point, -4, 3. So here's -4, 3, right here, -4, 3. Okay? And is perpendicular to this line. So meaning that whatever this line looks like, it's got to intersect this blue line at a right angle. Okay, so that's what I'm interested in. So I'm interested in the equation of that line. Okay? All right, so just like we did before, let's use point slope form, just like we did in the first problem in 1A, 1B, and then eventually 2A. Let's use point slope form. All right, so let's go to that one. All right, so listen carefully now. So point slope form, so this is 2B. So point slope form. Y minus y1 equals the slope times x minus x1. So do I know a point on this line that I'm trying to draw? Yes. What's that point? Right here. You're given that, right? That was this right here, -5, -1. Oops, sorry, -4, 3. So -4, 3. So this is x1, this is y1. Okay, all I need to know is the slope, though. Okay, I need the slope of that line. Well, here's what you're asking yourself. You're saying, okay, if I knew the slope of this line, then I know the slope of that line. So can you find the slope of this line? Yes, you can. You can find the slope of that line. How do you find the slope of that line? Well, the slope of that line, remember, slope-intercept form. You know this point here is, I didn't mean slope-intercept form, I mean the slope formula. This point here is 3, 0, right? And this point here is 0, -5. So the slope formula is y minus y1, y1 minus y2, or y2 minus y1, doesn't matter. y1 minus y2. Now remember, the denominator does matter how you write it. So you see how I have y1 first, and I must say x1 first. x1 minus x2. Okay, so now let's go ahead and label this one x1, y1, and this x2, y2. All right, and so let's plug it back into here. So I get the slope will equal y1 is 0, so I get 0 subtract a -5 divided by x1, which is 3, subtract 0. Well, 0 subtract -5 is a +5, and then 3 subtract 0 is 3. So the slope of that blue line is 5/3. So that means the slope of the perpendicular line, the slope of this line here, has to be what? And it kind of makes sense that slope is positive because the line rises. So the slope is, so if this line's perpendicular, see how it's falling? Then the slope better be negative, right? And it is, because how do you find the slope of this line perpendicular? You take this slope and you take the negative reciprocal. So the slope then would be the negative reciprocal of this. And what's the negative reciprocal of this? A -3/5. -3/5. All right. So make sure you understand how we had to find the slope here. So we had to find the slope by the fact that we knew 2 points, and we used the slope formula. y1 minus y2 over x1 minus x2. Or you could have said y2 minus y1 over x2 minus x1. Does not matter. You'd still get 5/3. All right, and so let's just go ahead and by the way, I can draw this line now if I want to, because you know the slope is -3/5, right? So from this point, I'm going to go down 3, 1, 2, 3, and then to the right 5, 1, 2, 3, 4, 5. So here's another point. And then if I connect those, and remember my points are thick, so it kind of looks like this is a right angle, doesn't it? So what I'm trying to find now is the equation of that green line that you're trying to find, the equation of that green line. Okay, so here we go. Y minus y1, which is 3, equals the slope, which is negative 3/5, times x minus x1, which is negative 4. Now remember, the direction says they want you to write this in slope-intercept form. Slope-intercept form. So you got to get y by itself. So we're going to, well, first of all, let's go ahead and rewrite this as x plus 4. That's important. Make sure you do that. So y minus 3 equals negative 3/5 times x plus 4. And now we're going to distribute. Okay? So I get y minus 3 equals negative 3/5 times x is a negative 3/5 x. A negative 3/5 times 4 is a negative 12/5. Okay? Adding 3 to both sides, just like this, combining like terms, I get y equals negative 3/5 x. And then just use your calculator. So if you use the calculator, I get negative 12/5. So negative, negative. Make sure you press the negative symbol. Negative 12 divided by 5. And then plus 3. Plus 3, press equal, and you get 0.6. Now, almost all of you should know that that's 6/10, right? Which reduced is 3/5. But if you didn't know that, just say second PRB, press equal, and you get 3/5. So plus 3/5. All right, so that's the equation of that line. So there's your answer in slope-intercept form. Slope-intercept form. So let me tell you what you've just found. You just found this right here is the equation of that line you're interested in. So this is the equation of this line. Y equals negative 3/5 x plus 3/5. And it kind of looks like it looks like the graph crosses. Remember, this is the y-intercept, 0.6. So doesn't it look like it crosses around 0.6 right here? Okay. All right. So that's what you were finding. And then finally, C. Let's look at what C says. So you see how it helps to kind of visualize what you're dealing with? It does help. All right, 2C says this. 2C says, all right, so again, same information. You want to write this in slope-intercept form, but this time the graph is perpendicular to the line whose equation is this, okay? And that line that I'm interested in has the same y-intercept. All right, so I'll make it too difficult. It looks like, what in the world are you talking about? Well, okay, so you have the equation of this line, right? So you're interested in this line, though. That line you're interested in is perpendicular to this one. And those two lines, you're told, have the same y-intercept. That's all you're told. All right, so let's first of all get this in slope-intercept form. Let's do that first. So 2c. Okay, so we have 4x minus 3y equal negative 6. So in slope-intercept form, let's go ahead and subtract 4x. I can show you what, and some of you will do that, and you may mess up if you're not careful. So let me go ahead and show you what you need to do. So combine like terms, I get negative 3y equal negative 4x minus 6, right? Divide both sides by negative 3. And then reduce, simplify, I get y equal. All right, now here's what you need to do. You need to write this as two separate fractions. So negative 4x divided by negative 3, just like this. And then minus 6 divided by negative 3. But you got to rewrite this. So you got to remember negative divided by negative is a positive. So this becomes 4/3 x. And then negative 6 divided by negative 3 is a positive 2. Okay? So this right here, though, that's the slope-intercept form of this line. Okay? So I want to ask you this. All right, now listen carefully. What is the y-intercept of this line? So the y-intercept is what? Is 2. That's your y-intercept, right? So what they're saying is this. What this is saying is that the equation you're interested in, also has the same y-intercept. Okay? All right, so listen. What's the slope of this line? Slope is 4/3, right? So what is the slope? So therefore, the slope of the line I'm interested in is what? Remember, they're perpendicular. So if the slope of this line here is 4/3, then the slope of the line I'm interested in is what? Negative 3/4. Okay? And here's the thing. Remember, they want you to write in slope-intercept form, right? So you can think of it two different ways. So if I go to slope-intercept form, y equals mx plus b, do I know the slope of the line I'm interested in? Yes. Do I know the y-intercept of the line I'm interested in? Yes. So I have the answer right away. So my answer right away is y equals negative 3/4 x plus b, which is 2. There's your answer right there. You're done. Now, you may say, but I want to go ahead and I want to do it like we did before. I want to go ahead and I want to go start directly to point slope form. Okay, well, let's do that. Let's go ahead and do that. All right, let's go directly to point slope form. No big deal. So just keep in mind, though, that you see the difference between A, B, and C right off the bat is that you were given right away a point on that line. Okay? Here, were you given a point on the line? No, but you were told this. They have the same what? Y-intercept. So once we found slope-intercept form of this line, I now knew a point on that line. What's a point on that line? 2, 0. So I know a point of that line, not 2, 0, I mean 0, 2, is 0, 2. That's the y-intercept. 2, 0 is an x-intercept. So that's the y-intercept, right? 0, 2. So here's your x1, here's your y1. And you know the slope is negative 3/4. And you just plug into the formula. Y minus y1 equals the slope times x minus x1. And so I get y minus 2 equals the slope, which is negative 3/4 times x minus 0. And I want you to see something. So if I get y by itself, do y'all agree? I'm going to go ahead and rewrite this like this. Do y'all agree that negative 3/4 and then x minus 0 is just x, right? So that's just negative 3/4 x. And then adding 2 to both sides. Adding 2 to both sides. I get y equals, this is 0. I get y equals negative 3/4 x plus 2, which is what this is. Okay? So it didn't matter which one you used. Just the fact that these were y-intercepts, and they were the y-intercept of the line I'm interested in is also the same y-intercept as this line. Then I went directly to slope-intercept form. Although you could have done this and got the same answer. Okay. All right. So if you want to graph it, you can. Just what you would do. Just to kind of show you. So, by the way, the answer to our this is the answer right here. Oops, either one of those. Okay, is the answer. Okay. So if you want to graph it, this is what's happening. So remember, we graphed this line first. Okay, and so to graph that line, you need to know this is right here. So you need to know the. So we're going to use the y-intercept and the slope. So the y-intercept is 2. Y-intercept is 2. And the slope, remember, is 4/3. So I'm going to go up 4. 1, 2, 3, 4. And then to the right 3. 1, 2, 3. And I'm going to draw my line. And when I do that, this blue line here has this equation right here. So that is 4x minus 3y equal negative 6. Okay? But I'm interested in the line, though. I am interested in the line that has the same y-intercept, but is perpendicular to this blue line. So here's my y-intercept, the same one, right? And it's perpendicular. So I'm interested in this line right here. Okay? That's what I'm interested in. So I'm interested in the equation of that line. All right? So look. So you know the slope of this line here is the negative reciprocal of this one. So the slope we saw is negative 3/4. So from this point that's on the green line, I'm going to go down 3, 1, 2, 3, and to the right 4, 1, 2, 3, 4, and then I'm going to draw my line, and that's the equation I'm interested in. So I'm interested in the equation of this green line, which we found to be y equals negative 3/4 x plus 2. Y equals negative 3/4 x plus 2. All right, and so that's what you're doing. All right, so it does help. It does help if a lot of students, they do have trouble understanding what's happening here, but if you look at it in terms of this situation, in terms of graphing, it does make the understanding a lot better. Okay? All right, so that is the end of this lesson on writing equations of lines, dealing with parallel and perpendicular.